Hello and welcome. My name is Ryan. I'm also known as RM2K Dev, and I have to apologize that I forgot to say goodbye in the previous video. Now, let's begin where we left off. In the previous video, we created this map. We had our hero walking across it. That was from the video before. This time, I'm going to show you some cool techniques to bring in objects. Now, these objects are going to be off the grid, so to speak. They're not going to line up with the grid, and this is going to give our game a really organic feel. And basically that's what we're after. We want our games to have the most organic feel possible. Part of that is going to be collisions, but we'll handle that in the next video. So what we do, let's create a sprite. We're going to use a sprite for this because it is actually going to be an object and not a tile on the map, so to speak. Let's call this object tree. Begin by selecting edit sprite. Like we did in the previous video, we're going to use this create from strip button again, except this time we're not going to select the character set. We're going to select the tile set that we were using. So now we get this lotus strip image. What you can do is you can scroll down until you find that the tile that you want to import. Mine is this tree down here. Now if you just click, you'll get this 3 little boxes. Maybe you get 1. It depends on the settings that you had last time. But bring it roughly around where you want to begin your import from. And the number of images I want to import is 1. There's only 1 image per row. Now this image is actually 64 by 64, and I know this because one tile in this tile sheet is 32 by 32. So we have 4 of them. We need 64 by 64. 64 wide, 64 high. Now by dragging this little square around and getting it as close as possible, you're going to see some numbers over here in this corner here. I think I've actually selected that spot on. But what you would do is, if say you wanted to import, say you were slightly sloppy, you basically just begin by subtracting or adding numbers to get that square till it looks right. So I know that the 0 is going to be the border edge. Now 1502 is obviously not enough because we're slightly above the line, so let's add 3. That's still off by 1. Let's make that 4. That's spot on. So basically we've created a selection rectangle around this square that is spot on. Now if we select OK, that will chop that tree out, and you can see that here. Click the little tick box to OK save your changes, center the sprite and select OK. Now the next step we need to do is we need to create an object. We're going to call this object tree. Set the sprite to the tree. Call that object tree. We need to tick this box called use physics. And you might be wondering why I'm going to use physics for this. We're creating a modern role-playing game here. So previously, I know a lot of people use the place free for collision detection and things like that, but Game Maker Studio has included box 2D physics. Now, this is an extremely optimized and fast physics library that allows us to do quite advanced physics simulations inside of Game Maker. It's only natural that we use that. So by selecting the use physics button here, we've basically enabled physics on this object. What we need to do is create a collision shape so that our player can actually collide with this object in a specific way. So what I like to do is I click this button here that says shape, and then I tick modify collision shape. That will bring up this window here. Now this allows you to edit the shape. So what I'm going to do is I'm just going to add another point. I'm going to place that point at the bottom of the object. Just drag the points around until you've sort of got the shape of the tree. It doesn't have to be perfect because the player is not going to see this. They won't see this object on their screen. There we go, we just got to center that. Now what we'll do is we'll move this top point here. Now what you'd be thinking is to do this, but what this means is that the player wouldn't be able to get behind the tree. So the collision shape necessarily shouldn't be here. It should actually be further down, say here. Just like that, maybe a little lower than that even. Just to the point where the player, let's go there. So we can have our player move all the way freely back here behind this tree, but they won't be able to move within this triangle here. Select OK, and then select OK on our object. Oh sorry, I've named the sprite object tree. This should be named sprite tree. Sprite tree, there we go. Now we can call that object tree. We select OK. We go back to our room. Now this time we need to enable physics. So come over here to the physics tab, tick this box here that says room is a physics world. Now in our gravity, because this is a top-down game, we don't have gravity along the y-axis. We have gravity along the z-axis. So we're going to set this to 0.0, so we don't have any vertical gravity on our screen. We do have gravity, however, in our z-axis, and that's going to be controlled by our z-depth, which I'll go into a little bit later. Go back to our object tree. One other thing we need to do is that we need to set our density to 0. And what this means is this tells the Box 2D physics engine that we're not going to be able to move this object. This object is of infinite weight. It cannot be pushed, it cannot be moved. Now we go to our hero object, we need to do the same thing. We tick the use physics button, set our density to 0.0. So this time we're going to use a circle for our character. So press OK on that. And what I like to do is I like to make the collision detection box slightly smaller, maybe by 16 pixels, just so that when you do touch things it looks more natural that you're touching the side of the image. And also when the player rotates to the right sprite as well, he's only going to be he or she is only going to be encapsulated in a portion of this circle. So select OK. Density is now 0. Press OK. Press OK. Now we need to place some trees in our room. So for our map here, what I've done is I've sort of created these grassy patches, and I'm going to place trees. I think we're going to surround the grassy patches in those trees. Now what you'll notice is that all of these trees are currently being snapped to the grid, and this would be typical of an engine like RPG Maker, but currently we're using Game Maker. This gives us a lot of flexibility in terms of how we place things. So begin by placing a tree object. Now what you'll see is as we move this around, it snaps to 32 by 32. We could get around this by setting our snap X and snap Y to 16 by 16, but we would then also be snapping to a grid. If you hold down the Alt key, you're able to freely move these images around. So begin by dragging in some trees, and now these can be of any sort of pattern that you like. So I'm just going to block this path up here, maybe block this path over here, place some trees like this, and we begin by shaping out sort of a rough map for our player to be traveling on. So we want to block off these sort of openings, per se, like that, and create a bit of a forest outside. There we go, just like that. So once you've placed a sufficient amount of trees that you do feel is appropriate on the map, and again, we won't run into any performance issues with this. Like I said, Box 2D is extremely optimized. If you've seen the latest games, the latest in 3D first-person shooters, there's thousands and thousands of physics objects on the screen at once. So in dealing with a small RPG map like this, or even a larger map, we could have, let's say, maybe 500 to 600 physics objects on the screen at once, and you know, a fairly decent gaming PC, which is kind of your target audience, should be able to run that perfectly fine. Let's place a couple of these trees on the grid as well. It sort of helps to bring the focus back that the game does have a grid, because you don't want your game to look too what's the word? You do want it to have a pattern, a recognizable pattern, and that does help making your game look a little bit better. So some of these trees will be placed on the grid, and that just helps to bring the player's eye back to the fact that there is a grid in this game. What you'll notice is there may be some collision issues here, so let's open this path up just a little bit. There we go. Let's move our hero down here. So let's play our game and have a look what happens. And what you'll notice is we're unable to move. And this is because we've enabled physics, so we're no longer handling our player's positioning using the X and Y variables that we previously were. This time we need to be using the physics object. So go back into our hero step event, and you'll see, because we named this script handle input logic, we know very easily that this is where our input logic is going to be handled. Open this script up, and change all of these X and Y variables to their physics representations, which is PHY position X for the X variables, and for the Y variables it's PHY position Y. And what this means is that you're actually moving the physics object around the map. The sprite just comes along for the ride. The sprite on the screen just follows that object around, basically. So by moving the physics object, we're going to get inherent collisions. So let's run this object and see what happens. So let's run the game object. Now we're able to move around again, but you'll notice the collisions aren't working. That's because we have to tell Game Maker that we want to collide with this tree. So, in our hero object, we add an event of type collision with the tree. By doing this, you would think that this works, but it actually doesn't. You actually need to put a script inside of this action bar. So what I like to do is I usually add a script called collide with, and that's all you need to do. Without a script in here, when you press the play button, the game maker, I don't know what they call it, not the interpreter because they've moved to the new compiled system, but the packaging system, when you hit the play button, it goes through all of these events and it finds an event that doesn't have any actions and it removes it. This is obviously in an effort to save space or improve performance, because there's no point tracking an event that doesn't have any actions. So we need to add an action, even if it's just a comment. That will make it a valid action. So now when we play the game, you'll notice we're still able to collide with the trees. We need to find out why that is. And that's most likely because our hero doesn't have a density. Let's add a density of 0.1. We'll try that again. There we go. So two objects with 0 density obviously can't collide because they don't weigh anything. Now what you'll notice is we have some issues here, and this is called depth order. So we can get around this with a very simple script. Very simple. In the tree object, we need to add a create event. And all we need to do here is we need to scale their depth to a number between 0 and 1. Maybe not 0, I can't remember, sorry. I can't remember exactly what that number will be, but basically the tree's depth is equal to their Y position on the screen. So however high they are and however low they are on the screen, that is going to be a contributing factor. We're going to times that by -1. And that's it. That will basically order everything from top down. If we press the play button again, what you'll notice this time is the trees will all be in correct order. Trees that are lower than other trees now are above the existing trees, and our hero can walk behind them. But you'll notice there's a problem as well. If we do come underneath the trees, you'll see that we're still underneath the tree, even though we're in front of it. You see that? It's kind of hard to see because the collisions are so tight. So let's go and we'll just edit the collisions just a little bit to demonstrate this. I'm just going to bring the corners of this tree in just a little bit so we can see exactly what's going on here. So now what you'll be able to see is that we're actually underneath the tree, even though we're above the tree. So what we need to do for the player is we need to add this same script. So in the step event, we need to add a new script. We'll call this one here depth correction. Depth equals, now this time we're using the physics representation, remember? Physics underscore position underscore y times by -1. Let's move this above the input logic because I think this needs to come first, then we can handle the input logic. Now what you'll see is that we should be above the tree until we're actually behind it. So until we get to a certain point in that tree, we won't come through. We won't come through to the front, basically. What you see is we're in front, and then when we get to a certain point, we will snap to behind the tree. I can't demonstrate on. Oh, here we go. I'll demonstrate on this tree here. So we can get behind the tree up to a certain point, and when we get to a certain point, we come in front of the tree. And this gives us a sort of sense of depth in our game, and basically allows us to position things quite easily, so we don't have to worry about their ordering as well. So now we've got collisions, we've got physics representations of our objects, we have a system where trees and various other props in our game can appear off the grid, so to speak, and it's starting to look a lot more like a game now. So once again, this time I won't forget to say goodbye and thank you for watching. Please follow me on Twitter. My Twitter address is @rm2kdev. Subscribe to my YouTube channel and please leave some comments and some feedback on these videos. If there's any features you guys would like to see, please feel free to leave those in the comments as well, and I will get through those as soon as possible. Once again, thank you for watching.